Hi guys, I'm sailing upwind today, and that made me think of how to calculate the distance you have to sail to your target and the time it takes when you are sailing at an angle when you are tacking back and forth like I'm doing now. So let's say I have my target at 10 miles that way, and I cannot sail that way because the wind comes from there. So actually, the formula to calculate the distance you actually have to cover to get to your target is distance to target divided by cosine of the angle that you are sailing relative to the target. This may sound complicated, but it is not. I'll try to make a little diagram so that you can understand what I'm talking about. Okay, so this is your target, and the wind comes from here, and let's say this is you, and this is the distance to target. We'll call it dt, and you're going to tack back and forth like that. To get to your target, and you have the direction of sail, and this direction makes an angle. Let's call it A, angle of sail, A, and that's the whole distance you are sailing. We'll call it distance sailed, the distance you are actually sailing to get to your target. We'll call it ds. And then the formula to compute the distance is distance sail equals distance to target divided by cosine of the angle of sail. That's the formula, and it's not really complicated, because for each step you will do a distance towards your target, which is this distance multiplied by cosine of A, which is this is cosine of A, and for each step you will do another cosine, and so on and so forth, so you reach your target. And so if the distance to target is 10 miles nautical miles, and you sail on an angle of 60 degrees, then you will have ds equal 10 by cosine of 60, which is 0.5. So this means 20 nautical miles. I hope I can make myself clear now. Let's say for now that I'm taking back and forth at an angle of 60 degrees to my target, and the wind comes straight from there. So for a cruiser, 60 degrees to the true wind is quite feasible. And remember, that's the true wind. If you are sailing at 60 to the true wind, the apparent wind, the wind that you will actually feel on the boat, will be more like 45 degrees, and so it kind of gets close to the wind, and you won't be able to sail very close to the wind anyway. So 60 degrees to the target is quite a normal way of sailing upwind for a cruiser, not a competition boat, which can sail much closer to the wind. Anyway, so let's say I have 10 miles to go, and I am sailing at a 60-degree angle to the true wind. So then the distance I actually have to sail would be 10 divided by cosine of 60, and it turns out the cosine of 60 is 0.5. So 10 divided by 0.5 means 20 miles. So I have to sail 20 miles to get to my target, and then let's say I'm doing an average of 5 knots. That would mean 4 hours. And how about if I sail at let's say a 65-degree angle? Well, then I would have to divide 10 miles by cosine of 65, which is 0.4. You can easily check this out with the cosine tables on the internet and so on. And so 10 divided by 0.4 means 25. So I would actually have to sail 25 miles or 5 hours with a 5-knot average to get to my target, which is just 10 miles away. So that's just interesting way to estimate your time, and it's crazy how a tiny difference of 5 degrees, which is not much, can make a difference of an hour at 10 miles. And if you have to go longer than that, you just multiply the time. So yeah, some food for thought.